In this video, we would like to derive an expression for work done in isothermal process. Let us start by saying what is an isothermal process is. What is an isothermal process? The process in which temperature of the system is kept constant, always kept constant. Change in the temperature is zero. This is called as the isothermal process. This is a slow process. System is perfectly conducting to the surroundings so that the temperature will remain constant. This is the basic understanding which we have done in the other video too. Being temperature is kept constant here, Boyle's law is valid. PV equal to constant. That can be written like nRT because N is constant, number of moles. Universal gas constant is constant, temperature is also constant. So PV equal to constant equal to nRT. Now, if you start saying that, let there is small work done due to which volume is changed by a dV. Then we can write an expression work done as something like Fs, that is the force into displacement, say F into dx. In terms of pressure, force can be written like, as for the definition of the pressure, as force by area. So force can be written like pressure into area into dx. Area into dx is the change in volume. So dW can be written like PdV. This is the small work done for a small change in the volume. To get the total work done, we shall integrate this equation. Then integrate that above equation, integral of this dW equal to integral of PdV, where volume is changing from V1 to V2. Integral of differentiation of work done equal to work done equal to integral of PdV V1 to V2. Volume is varying from V1 to V2. If you notice the equation that we have got little carefully, you are trying to integrate with respect to dV, but the term inside is not in terms of V, this is in terms of P. So I shall convert that P in terms of this volume so that I can make the integration. For that, we can use this relation that we said, like being the isothermal process, pressure into volume is a constant. That implies what we can say as PV equal to nRT equal to constant. In the place of pressure, I can write nRT by V. See here, P is not constant, that is variable, varying this way, right? So in the place of P, I can substitute nRT by V. That implies our work done equation will become integral of, in the place of P, nRT by V dV, where volume is changing from V1 to V2. That implies work done is N, R, T are constants in this case because isothermal process temperature is also constant. Integral of 1 by V dV, volume is varying from V1 to V2. We have a formula in integration. Integral of 1 by x dx is log x. So integral of 1 by V dV is work done is equal to nRT log V, whose limits are varying from V1 to V2. Of course, it has a base of exponential function E as per the definition. So you can write this as nRT log upper limits V2 minus lower limit V1. Both are having bases. Log M minus log N is having a formula log M by N. That implies work done in isothermal process, W is equal to nRT log V2 by V1 base C. But I want you to be little careful in understanding one thing, that this base C is an exponential base, but what all the number system that we use is having a base 10. So we shall convert that base C into base 10. That conversion factor is 2.3026. It's a basic of mathematics. nRT log V2 by V1. Now I can write it as base 10. Normal numbers that what all we are having a base 10, now they can be directly substituted. That's the expression for work done in isothermal process. In this, N is number of moles of the gas, R is universal gas constant, 8.314 is its value in SI system. T is temperature. Be careful, this temperature is absolute temperature because we got it from the ideal gas. That shall be always taken in Kelvin, never in centigrade. Once you know all these factors, you can simply substitute, get the equation for the work done. So the most important point is, being temperature is kept constant, ideal gas law is valid, and we are using that very much here so that we can get an answer like this. This is how we can derive an expression for work done in an isothermal process. Thank you for watching.